Folks, in the last two videos, I told you that you are dependent upon oil, and there's just no way around it. You're either going to use oil directly into your vehicle, or you're reliant upon the crude oil production, because at some point, at some time during the day, you have came in contact with one of those components that are inside of crude. So, this is just the way it is. And we talked about the history of maybe not relying totally on gasoline for our vehicles, and with that was the incorporation of an electric vehicle that was back into the 1900s, 1800s, late 1800s, right? So we said that this really didn't take off like it should have continued to do well, and one of those reasons was the Model T. The Model T came out, it was a gasoline-based engine, and that gasoline-based engine was much, much cheaper, and people turned their backs against the electric vehicles back in the day. So once again, the technology is not new. If you think that the 2000s brought with it this whole swarm of new and innovative electric energy, electric vehicle, then you're mistaken, because this happened more than 100 years ago. You probably were not born during that time, but it happened. And we're just kind of late to the ball game, I guess we can say. So with that, I told you that we're going to talk about other components as well. And one of these components, other than gasoline, that was tried back in the day was ethanol. All right. So ethanol, the structures over here to the right-hand side is CH3CH2OH. This, of course, represents a carbon, and that represents a carbon, and carbon needs 4 bonds. So this is a carbon, 1 to the other carbon, so therefore it needs 3 more. This carbon, 1 in the center, 1 to the left, 1 to the right, it needs 2 more bonds, so that's going to be a CH2, and then the OH. The OH group here, this is the alcohol group, and anything with an OH is going to be classified as the alcohol functional group. Now, the reason that I'm going to introduce ethanol here is because ethanol you have made before. You made it in our CTC 145 if you've taken that class. And that CTC 145 class, what did you do? You took sugar, and you took a little bit of what we call pasteur salts, and you dumped it down into a flask with a little bit of yeast. And you let it ferment. You mixed it up, you let it ferment, you let it do its thing until it quit bubbling. And then you took it from the boiling flask and you distilled it. And you cleaned it up. And that distillation was ethanol. And hopefully you got around 170 to 190 proof. Okay? Well, this is going to get incorporated again. And one of the reasons we're talking about it one more time is because ethanol, again, back in the day, was looked at as a fuel source. Not gasoline, ethanol. That's right. This whole concept of ethanol gas at your tank currently today, that was nothing new. You're thinking 2000s, we started to ethanol blend our gasoline. Folks, this was done 100 years ago. This is not a new concept to the fuel industry. You might have thought it was, but it wasn't. So yeast typically is used to ferment the sugars, and sugars can come from a number of different sources, and particularly those found in crops. That is a very good source of natural sugar that we can play off of. So these crops, mainly corn, but corn, barley, and rice, sunflower, sugar cane, all of those are plausible candidates to make alcohol with. If it has sugar, if it has carbohydrate, right? We're going to go back and dig out some of those old terms that we kind of learned in the beginning of the semester. These carbohydrates, these sugars, these saccharides, they can be converted into ethanol. And the way that they do that is through a little bit of biological molecule called a yeast. Now, Brazil is the largest producer, makes most from sugarcane. That's where they get most of their ethanol from. Now, this is just one possibility to make ethanol. I can take a crop. That crop, like corn, can be used. That corn has a natural sugar content on the inside, or starch. I can take that, I can strip it down, I can throw in some yeast, I can throw in some foodstuffs, some initiators, some catalyst, and I can ferment this stuff and distill what we call ethanol in the very end. All right, well, this works great for produce like corn and barley and rice. But what about the woody stuff? Okay, what about trees? Or what about really woody branches, woody plants that come along? This is a little bit more difficult, but we can do it. The reason it's more difficult is because it's cellulose based. We have to break down that thick, rugged wood structure, not just plant material. But that cellulose is a sugar bank. All right, I do want you to understand that. Cellulose is a polymer, and that polymer typically is with a sugar. So we can do this. We don't call it just straight up ethanol, though. Whenever we do this with these woody plants, we call it cellulosic ethanol. We try to get a little fancy with that. So this is great. We can take remnants that's no longer used on these farms, this debris, these kind of dead limbs and branches and stuff. We can actually turn that into ethanol. It's more difficult. It's more energy requirement, but we can do it, and we can get ethanol from it. Another thing that we've looked at too in the past, recently of course, is something called switchgrass. And switchgrass really was started in Oklahoma. Researchers began to use, or look at least initially, the switchgrass and said, listen, this is going to be stubborn. It's not going to be like corn and barley and rice, but the switchgrass is kind of a blend between that and these woody kind of cellulosic ethanol blends. But we can use switchgrass. And the reason that they started to focus on switchgrass is because switchgrass can come back. We can chop it down, and it grows fairly quickly. And it comes back year after year after year. So researchers began looking at the switchgrass, which really isn't used pretty much for anything else, and they began to make ethanol from it. So the U.S. Department of Energy basically came around and said, hey, one of the main perennial crops is going to be switchgrass to make ethanol with. Not only that, but it's got 66% more potential energy than corn does. So if this is the way of the future at this point, and you want to make ethanol and you want to make it from foodstuffs, then you need to get away from the corn, get away from the rice and all the others that you've used before in the past, and you need to take a closer look at switchgrass, because this switchgrass stuff, it grows, and it grows fast, and it comes back every year, and you can keep mowing it down, and you can keep making that alcohol for us so we can sit back and drink it. 300 to 700 gallons per acre of ethanol can come from an acre of switchgrass, and you compare that to about max of 350 from corn. All right, so with a good crop, you could almost double or more than double the amount that corn could provide. A great alternative, a great resource for us, and they're looking more at that right now. In addition to that, ethanol is biodegradable. Ethanol, basically, when it gets released into the environment, it does eventually break down. It doesn't really cause us any problems. We get drunk off of it. Bugs get drunk off of it too. Maybe, I don't know. They could. In my mind, I hope that they do, in a way. Not you, but those bugs. I think that would be kind of funny. And ethanol also has many other sources, many other uses. These uses are, of course, antiseptics. It's used to treat methanol poisoning. So if you do try to make your own alcohol and there's too much methanol and you take a big swig of it, methanol can cause you to go blind. It can give you alcohol poisoning. Well, they take you to the hospital and they pump you full of good alcohol in order to compete against the bad alcohol. That way you don't have those symptoms anymore. Of course, it can be used in fuel. We see that at our gas pumps today. And it can be also used as various solvents, especially in the chemical field. Very often it's called the universal solvent. Universal basically means it pretty much dissolves everything. All right, well, this is great for a laboratory environment, right? Very often we have to look at this problem of what do things dissolve in? And sometimes I have to look that up to make sure that it can get dissolved in water. But ethanol is a pretty good universal solvent. It's one of the common solvents that we have around in the lab all the time. And the reason is because this piece of alcohol is organic-y. All right. So this would love those organic hydrocarbons, anything carbon-based, hydrogen-based. This part of ethanol does a very good job mixing with it. And then over on the right-hand side, this OH group, this is a polar piece because this oxygen has two sets of electrons, one on top and one on bottom. So that polar alcohol group, pretty important because this allows it to dissolve in things like water. That's great when we make mixed drinks at home, but if you're not legal age, again, just ignore that comment. But ethanol plays a role, again, in multiple things other than fuel. And the reason I bring up ethanol, again, is because right now at this moment, when you go to a gas tank, you're going to see a certain percentage of ethanol that's listed on that gas tank. And that's been blended with your gasoline sample. So the question is why? Why did they start doing this? And I just mentioned that this is not new. I just mentioned that they were actually doing this many years ago, before the 2000s hit. They had blended gas. More than that, though, they actually had entire things that were running off just ethanol. That's right, folks. Ethanol is an energy source. Ethanol burns very clean. Ethanol provides energy. That energy is the same type of energy that gasoline could provide. That energy can be pumped into a gas tank and it can run. In the early days, that's what was going on. Okay, so now we need to take a look at this and say, we had ethanol. Ethanol is common. We use it for a lot of things. Ethanol is safe. Ethanol is biodegradable. Ethanol really doesn't cause the pollution that something like burning gasoline would cause. You just told me that ethanol was used in gas tanks pretty much back in the day to run and operate things. So why aren't we using ethanol in our gas tank today instead of gasoline? Why is it an ethanol blend? Well, that question is going to be a little difficult to answer, but I'm going to try. Here's a graph. This graph is basically the world ethanol production. So if we take a look at 1975, which is where this graph starts, we see that the ethanol production is super low, right? And over time, what's happened is that we've had a slight increase over the years, and then in about 2003, 2002, somewhere in there, we began to grow exponentially. Something major happened here. You can tell what that was by the color of the bar. Right now on your screen, you're seeing a sagey green and more of an emerald green color. The sagey green color is ethanol used for non-fuel purposes. So this would be like ethanol that we would drink. If you look at that area, you're seeing that that area is not increasing very much, right? Sure, it's increasing a little bit. There's more people now than what there were before, and there's more drinkers now than what they were before, and maybe we like to drink a little bit more than what we liked before. But for the most part, this increase is not that significant. Yeah, it's going up, no big deal. But if you look at the emerald green color is where it's at. This is the fuel ethanol. Ethanol produced specifically for fuel. Well, since 1975, it has went up, right? And again, there's going to be a reason. We'll talk about what some of those reasons are. But after 2000, what we're seeing is a surge, Another exponential growth. This is what's giving the graph its shape. Not the consumption ethanol, not the chemical ethanol, not the ethanol that's getting used as solvents for different purposes. This is ethanol for fuel. It's making a boom, and it's coming around quick, and we are seeing it take off a little bit after the year 2000. Well, ethanol can come to us in many different forms. We can produce ethanol many different ways, and this is one of the ways that we can make ethanol. We use what we call biomass. Well, biomass is basically vegetation. That's what we're seeing on the screen, right? At step number 1, it's saying biomass is harvested to deliver to the biorefinery. All right, so we're going down, we're chopping down things like corn, we're chopping things down like trees and bushes and whatever, and we're hauling it back to this location, we're dumping it off. Well, all of that in step number 2, it gets shredded. Of course, we want to increase the surface area to allow this process to happen a little bit faster and a little bit better. And we pre-treat it with some chemicals, we help it break down a little bit, we put it into the presence of heat, and this is targeting the cellulose that's in the plant. Again, that cellulose is basically sugar. And we throw in some enzyme. That enzyme basically does one job and one job only, and that's to take this cellulose, which is a very complicated polymer, and that enzyme's job is to take the polymer and begin to eat it. Yum, 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 right? And we get these little individual sugar molecules that come out. So it breaks the cellulose polymer down into its individual units. Those individual units are just different sugars that we learned about in the beginning of the semester. Well, then we throw in what we call microbes. Microbes will go in and it will target these individual sugars here. Think of these microbes as kind of like yeast, right? And their job is to eat the sugar. And then they pee out the product, and that product, their waste that they don't want, is ethanol that we do want. So we allow the yeast, or we allow these microbes to do their thing. They expel the ethanol out throughout this process. We capture it, we bottle it up, and then we distribute it. That's one way that we can make ethanol. Not the only way, but one way that we could do it. And the reason I'm showing you this is because this ethanol is made from foodstuffs. It could be, at least. And this is food chemistry. So here we have a food product that is strongly tied to the ethanol world. And once more, ethanol is used for many different purposes, not just drinking, but everything. All right, well, here's another chart. It basically gives you this into more detail. It's just not as pretty. There's more detail in it, so it's more wordy. But here's my biomass. This gets milled. It gets chopped up, little bitty pieces. We add a little bit of gypsum, add a little bit of acid, add a little bit of lime. That's not lime as far as lime trees, right? It's not tequila day. This lime is basically alkaline lime base. And all of this is what we call pre-hydrolysis. Hydrolysis, hydro, of course, means water. And lysis, anytime you see that word, means cleave. So this is pre-water cleaving. All right, so in the next step, what happens is the saccharification, not sacrifice. Saccharification. I see the word saccharide in there. We know that this is really looking at the sugars now. So this is the process of breaking down the cellulose into the individual sugars. In order to do that, I told you we need an enzyme. That enzyme is called cellulase. Anytime you see the word ACE in enzyme world, this means this is a molecule that is specifically designed to act on that word that's attached with. So ACE, and this term here in the front is celu. So this means that it's a molecule that targets cellulose, because I see cellu in front, and it breaks it down. That's what the term ACE typically means in enzyme universe. And then we throw in a little bit of yeast. That yeast, of course, is the microbe that's going to eat the sugar and pee out the ethanol that we want. Then we're going to have to do a cleanup process just like you did in the summer when you were with us if you took the 145 class. And that distillation is basically going to fraction off a component that we're going to call ethanol. And this ethanol is our major product that we want to keep here in this step. And then there's actually some leftover crud that's there as well. All right, this leftover crud, that all can go through a scrubber. That can be processed into a different way. We can generate some CO2 out of this. As you can tell, there's a split off here after the sugar and the fermentation step. Lignin can go in, a burner and a boiler can go in. That produces steam. That steam goes through a scrubber to make CO2, and the steam goes up and out, and it can also basically kind of heat up this acid and almost in a way recatalyze it one more time. So this is just more of a detail of how biomass can actually be converted into ethanol on an industry scale. I also told you about switchgrass, right? And I said that switchgrass is one of these things that's beginning to look at. We can make ethanol from it. It grows back. It's a very hardy thing that can grow in pretty much any type of soil at all. And here's an image of what switchgrass actually looks like. So again, this is not food. This is nothing that we would use for really any other major purpose, but it is something that we could use now on the industry side of the house to make ethanol with. And ethanol, once more, is multifunctional, multi-purpose, but it's also tied to the fuel industry. Ethanol production capacity by state. Well, if we are relying on food crop product to make the ethanol with as one of the versions, then of course the states that have more of the farmland are going to be able to do this for us. And if you look at the red area of the United States map, that red area is going to be the super focus of ethanol production in the United States. Right there is the heart in the United States of where our farmland is at, and right there's the heart of where our ethanol is at. So states like Iowa, Nebraska, Illinois, Minnesota, and on down, all of those are great ethanol production states for us. So their economies are specifically tied to their farmland, which is specifically tied to ethanol production that we use for many purposes. Again, I keep saying it over and over and over, and one of those is fuel. All right? So that's where this video is going to stop. In the next video, I'm going to pick up with this image, and we're going to go on, and we're going to talk about when we decided to add ethanol to our gas, right? If these are the states and their economies really are driving force with ethanol production, crop production, farmland, this is where it's at, folks, as far as the ethanol world and farming goes, then at some point in time, we had to make the decision of putting it into a gas, and we have to talk about why. When did that happen? Why did we do it? And was it done before? And you already know the answer to that question. The answer is yes. We were running things off of ethanol, just only ethanol back in the day. So something had to happen. Something had to change, and we're leading up to that. But I've got to go through a little bit of backstory before I do. So in the next video, we'll pick up from here, and we'll have some more chats. So get you a cup of coffee. Hope it's not late at night. I hope you're not watching this at 1 and 2 in the morning, but if you are, good for you. I'm glad that I'm with you at 1 and 2 in the morning, and we can have this conversation and chat. Just make sure you pay attention. Make sure you take some notes.